Okay. Pause. Yeah, it's Coffee Compiler Club. Looks like a short meeting today, or small meeting today, anyhow. You're being recorded live. I'll throw it up on YouTube in an hour or two. Open mic, say what you want. Anything to do with compilers and language runtimes, all fair game, and that's good enough. And I'll open with a short AA status update, and then we should go to questions and see if anyone wants to talk about something. So I claim I got my theory thing hacked out. So that's been a year in progress. It's been a long time.
What's your theory thing?
Yeah, theory thing. I've got a combined typing algorithm, a type inference algorithm based off of a combination of Hindley-Milner style inferencing and the sort of classic forward flow typing theories you get out of C and Java typing. So it's strictly stronger than either one. So I can find more facts about the program and type more programs than either one alone. Bunch of other extensions to Hindley-Milner that came in at the same time.
Do you have subtyping? Like
yeah.
You do?
Yeah. Yeah. Yeah.
So I'd heard that Hindley-Milner doesn't work well with subtyping.
That's correct.
What is the problem and how did you fix that?
So the actual, like when people say subtyping from the theory side, you get all kind of funny responses about what they're trying to do and how they go about doing it. I moved away from doing union types because I don't like the asymptotic runtimes that come out of that. And I'm doing the typed records. So if you have a record that has some set of fields, you can tell that you have the right count, that it has what you think it has or whatever, it's well typed. If you have another record that has a strict extension of those fields, one's a subtype of the other, just by fiat, just by declaring it, it can be used, in the context of the first one can be used. So the fields all have the same type, the same name, that's sort of the rule on it. This is structural subtyping, not duck typing, because duck typing is untyped in that sense. So it's strongly typed. It's not nominative, but there's an easy hack to make it nominative. And that's just add a hidden field with your special name that you only allow in if you also have all the matching fields. Then the same theory all works fine.
Wait, what do you mean nominative? Nominative. So it's not nominative, like names type.
Names. Yeah. So structural typing says, I have a thing that computes distance between point-like objects, requires an X and a Y field, requires two things that have an X and a Y both, and it does the obvious math. Okay, but I don't need them to be declared point objects. I just need them to have an X and a Y. That's structural typing. So nominative typing says something like, I have a Java number. Here's Arthur. I have a Java number, has subtype as an integer and a subtype of a float. And wherever I want to have a number or an integer, I have to have a thing called integer, not a Java object that has a single value field that holds an integer.
Right. Yeah, I call that nominal, but nominal.
Okay.
That means if there's a name there.
Yeah, there's a name. Yeah.
The fields match up or the members.
Right. Well, the fields have to match up as well. Okay, hang on. I'm trying a new.
Yeah, so it's like in addition to structure has to match, also has to be a name. Otherwise, it's not the same thing. But anyway, so that's
yeah. So all right. So so this is not the field layout thing is not my work. I just took somebody else's work on this, and they said, hey, we could do subtyping things. And then I found this other guy that says, hey, I can do subtyping things. And I found a third guy that says, hey, I can do subtyping things. And I started working through the field, working through the papers. So there's a general theory going around, and it kind of depends on which angle you want to look at it. The Hindley-Milner folks come at it from a couple different directions. Somebody likes constraints, and they show a subtyping relationship, which is not a classic Java or C# or C++ subtyping, but that just means they can handle more than one more than one thing, it turns into, I want to say, intersection types or union types or something. Union types, I guess. And damn it, this is like, I'm trying a new strategy for recording people coming and going and logging them in, and it requires more thought because it's new. So it breaks my train of thought here. So anyhow, I stared at these other two out of the 3 papers that all said subtyping things. I stared at them all pretty hard. I implemented one. I tried to implement a second. I discovered that I couldn't install Scala on a Windows machine anymore. Everyone in the Scala world says, yes, it works. Do this, and this hangs. And then you go deep into it and they have a bug they've known about that's hanging, that's fixed, and it's been hanging, and it's been fixed, and it's been hanging, and been fixed. And that's the state of affairs for the past 5 years. So the current state of affairs is I cannot install Scala, so I cannot download this guy's 500-line Scala demo, so I can't actually run his code to see that it does what it does. I would love to go at least do a timing test. I claim I can type all the things he types. I copied many of his test cases into an AA variant, and away I go. So it's there. So this is for Cameron and Arthur. This is I claim I got my theory sorted out. It's been like a year in the progress, but every test has passed in every possible mode, and I kind of went hog wild on the where I could on the testing side of things to try and break things, and I think it's there. So it's.
You fuzz it.
Sorry, go ahead.
It looks
Did you
like
fuzz it?
Okay, when both of you talk, Discord or screws up. So Arthur first.
Yeah, you said that you tested it pretty well. Did you fuzz it?
No, but I could, and halfway. So I took 70 odd test cases that I had another guy like do piano arithmetic, build up like some pretty seriously ugly looking things. So he's doing piano arithmetic and he does a bunch of other stuff. He does subtyping tests, and I added a bunch of subtyping tests, and I added a bunch of null pointer tests, and this, that, a bunch of these things. And then I fuzz the work list, which forces order of visitation. So the algorithm's work list algorithm, it should come to the same answer. It's Church-Rosser, one-step complete kind of thing. It'll come to the same answer in the end, independent of order. I do fuzz the order a lot, and that chased out the last set of bugs. I haven't written or haven't grabbed an actual fuzzer, and at this point I could. That's not a bad answer. I don't know if a type fuzzer will fuzzer to a type thing. Like I have this is done on the AA core AA language piece. It's just for doing theory work. It's essentially a lambda calculus with fancier types.
Yeah, there will be a good question how to validate the result on some random input, but at least you can check that it's not crashing.
No, that's a good answer. And then the input should be fairly easy to generate. All right, I'll put that on my to-do list. That's a good answer. So this happened, middle of last week, and this week or middle of this week, I guess. And this last couple of days, I've been looking over the core AA code base and deciding it's time for some big hacks because of some stuff I wanted to do for a while, but now that the theory side seems solid, knock on plastic. I'm doing my tech debt cleanup and then going to where I need to go with dragging the theory along, or the theory dragging the semantics along, or something. Like my integers don't allow me to do like hash and EQ as function calls don't happen on integers, and I want to change that. That really makes me box all integers, at least during typing time. And then I have to guarantee to unbox them for performance coming out the other side. So that's what's going on now. People are showing up. Just a slow start. The holiday comes, I imagine it gets even slower. So
really what you want with respect to the boxing, Cliff, is that the code is written as if this is an integer object, and yet it doesn't have to be boxed in order for that code to run. That's the model we took anyway. I like it. So it's, you know, 'cause
Okay.
it doesn't require boxing for object methods on things that you know internally are implemented as primitives. I don't know if you can hide it as easily with the choices you made, because you're not really trying to pretend that everything is an object like we do.
I am going to treat an integer, how do I say this correctly? I'm going to treat it like an object. That's the box part. Except there's a hard guarantee that it boils down to a primitive in the end, or you have admitted that you want it to stay boxed.
Mhm.
So you'll write integer-like things and they'll behave like integers. You can pass them to things that you might expect to only require an object and they'll work, and I'll clone typically to avoid having to box. And then if I can't get rid of it without egregious cloning, or there's some other constraint, I'll throw a type error at you, a code performance error at you, and you have to come through and admit, yes, please keep the boxing. But
So our rationale is that most of the time when you're dealing with an int, you know it's an int.
yes,
So the only real problems with boxing are when there's a ambiguity between the developer and the runtime, right? So where the runtime has to mix together things that are real objects and things that are not real objects.
yes, exactly.
And it can't predict the pattern of mixing, right?
Yes,
Because
that's where I'm at.
if you can predict it, you don't have to box it.
Right. That's where I'm at.
Cool.
So,
cool.
so the guy has to come, you have to mix them, like really jam integers and strings into an array, into a mixed array. Something stupid like that. You put, you know, animals and cats and dogs and numbers, 5 and pi. I'll come through and complain at you and say, you got a box. And then it turns out that under the hood, I'll have kept it boxed during the typing time. It comes down to, you know, code gen. Of course, they will all clear out. In fact, it'll clear out as where I'm at now. It'll clear out during the typing time, but it'll start boxed so that I have access to things like .hash and .eq and whatever. I don't know what other non-operators. And it turns out I'm going to throw the operators on the EQ thing too. So all your add, subtract, multiply, divide will start by doing an operator lookup, which will just be a field lookup on the left-hand side, which will be the boxed integer. So that means I have, in the start of the world, I'm inhaling a pile of AA code, which builds the int type from even smaller parts. And the thing that does the primitive is actually a hook straight into the Java. It's a Java class for name.
Right.
Special syntax allowed during this parsing time only that says $$ Java class name injects either a base type or a base function call.
So Alan, you're mostly working on Scala, right? No? No.
You were doing your own language thing, or you're looking at it.
Yeah, so I'm working on Stroscot. So like, I mean, last time I think I said it was model checking.
Yeah.
That's like half of it. The other half, I mean, like, I'm discovering as I go along that like most of the model checking stuff has actually been working on term rewriting systems.
Yeah.
So now I'm doing term rewriting system stuff, which is it's, I don't know, it's interesting. I mean, so like, I mean, it gives some amount of expressivity to the language, because you can say something like you can say like double of x is equal to times 4 of x, and so even though double is a function, you can also do like a code transformation. And
Is
so
that bidirectional? Like, so it can go either direction across the assignment?
No, so that's why it's called a rewriting system, is that it's always rewriting a left side to a right hand side, and it doesn't go the other direction. And so that's kind of where the tricky part comes in, is you have to make sure that the rewriting rules give you like a valid kind of equational theory, so that you don't rewrite something to do unequal expressions. That's
The other ones are that you terminate.
Yeah, and then there's terminating, which, well, that's what the other part, the part that I've really been struggling with, because it turns out that in lazy languages like Haskell, which is of course my second favorite language, and the expressions actually don't terminate. You can have, for example, a list that's infinite, like the Fibonacci numbers, and that if you keep applying rewriting rules to it, it never terminates. And so the question is, how do you handle an infinite stream like the Fibonacci number?
You have to put the laziness in the rewriting system. So he can
Yeah.
say, this is lazy, I won't look at it until some other term makes a direct reference to it.
So how do you tell the difference between slow performance and non-terminating?
Well, you don't, that's the point.
Well, it's simple. If it's slow performance, you still have a proof that it will terminate. You know, non-termination, you can't prove that it doesn't terminate.
Okay, I'm about to say,
Or
you could be
can prove
slow and terminating and not have a proof that you're terminating.
Okay. Yeah, and so like, you know, because like that's what I've learned is that, you know, type systems are really just termination proofs.
Yes,
So,
yes,
I mean,
yes.
and there are actually some papers I found. There's a paper on the untyped lambda calculus, and like they prove they provide a termination checker for it. And it's like based on checking the prefixes of the lambda terms. And so you don't need a type system, you don't need anything except to run this little prefix game to figure out if the prefix is changing or if it stays the same. And that proves the termination because it'll prove that the term is either expanding or contracting.
We have a
Let me see.
non-terminating type system, so
Yeah.
by design.
If you have a non-terminating type system, then you allow all this sorts of bad behavior of terminating systems. And so you don't want that. I mean, it's like, you know, it's kind of like, you know, what if you wrote a program that, you know, monkeyed with the registers and the assembly, right? I mean, it's like, well, you know, on the one hand, it's, you know, it is a program. But on the other hand, you know, you can't code with it. It's like, you know, you have to come up with a register convention system. And it's similarly, you have to come up with a termination system. So yeah, here's, I found it.
I've certainly been wrestling with termination and non-termination for the last, like I said, for the last year.
Yeah.
I got it, I think, you know, not going plastic. I think a fuzzer is a good answer, but I think I got it. But man, it's like, bitch. The other one I end up hitting is I stopped too soon. I stopped making forward progress, and all types are sort of super optimistically high, and they claim nothing executes as opposed to everything executes. So you either, you know, the termination, while for engineering the termination, it's easy. I just put a trip count on the inner loop of the work list and say, it went 100,000 iterations. I'm probably just spinning in a loop. And then I have to go, you know, debug. What is the last thing I've seen on this work list go by 1,000 times in a row? Oh, here I go. I'm flip-flopping 3 things back and forth in a little cycle, and they're just like, wee, you know.
I mean, that's kind of what I've been thinking about. There are these papers on like switching between eager and lazy evaluation. And what they do is they evaluate the term eagerly for some amount of time. And then if it takes too long, they say, okay, you know, I'll bet this is an infinite term. And then they switch to lazy evaluation.
And it's because the lazy is a lot more expensive to go evaluate on.
Yeah.
Yeah, yeah.
And so, I don't know. And the other, there's like a third thing, which is what I'm actually writing code for, which is, it's called optimal reduction, which is, the basic idea is you reduce a term in the minimal number of steps required. And
Yeah, how do you know the minimal number?
Well, the way you do that is you carefully track every part of the term, and you only evaluate it if you know it's necessary for the overall computation. And you also have to do all this very careful bookkeeping work to make sure that you never evaluate a term twice. And so it implements this complicated form of sharing in the terms.
Yeah.
And so like it's really good for church numerals. Like if you give it a church numeral, Like,
Yeah.
you want to
I-
like multiply two church numerals. It's really
No,
fast. It
I
just
don't.
does. It shares all the parts of the church numeral in it.
Yeah,
It does the
right,
computation really fast.
right,
And
right,
so like, but I haven't found any practical use for it,
right.
but it looks cool, so I'm implementing it.
Oh, there you go. Okay. These are great learning experiences.
And so I implemented it for the lambda calculus. So now I have optimal reduction in the lambda calculus. And then
Okay.
I found this thesis, and it turns out it's like this poor guy decided that his PhD thesis was going to be optimal reduction for term rewriting systems. And so that's what I'm trying to implement now is this guy's thesis. And I don't know, like it's kind of a half-baked thesis. He never actually implemented his system. He just kind of outlined how
Yeah,
one would
right.
go about doing it.
That's a polite way of saying that he couldn't make it work, and he wanted to publish partial results.
So
And his advisor, if he got his PhD, his advisor just wanted him out of there, kick him out, move on.
yeah, I mean, but like I figured out when I was implementing the lambda calculus, I figured out like a different style of the sharing graphs that like because like the existing sharing graphs, they have this thing called bookkeeping overhead, which made them slow. And like I figured out a way to implement it that I think avoids the bookkeeping overhead. So
Okay.
like it's actually, I mean, I don't know. Like I've tried it on one example and it seems to work. So
Right. So I wrestled with a lot of the performance issues. And I'm still screwing around with them some. The main one I found was during the term rewriting that the Hindley-Milner unify steps. There's a step they call fresh, make a fresh copy of a type and then unify. That almost always unifies 100% without any extra change or only minor changes. So I have a lazy fresh unified combined thing that walks the two types in parallel and only starts making things when they're not already effectively unified. And this cuts out like 99% of the allocation of type objects that would immediately die shortly thereafter. So there's some big performance gains that came out of that. And the other unrelated thing that I was doing here that, because you were talking about infinite term and lazy, is I do recursive types fully and directly in the type system, in the typing structures. Like types can have closed cycles. And anytime I can discover that I have a closed cycle with some finite duration and then it looped, I'll turn it into a real cycle. And everyone else handles basically cyclic types thereafter. And that keeps a lot of these infinite unrolling lazy things bounded. If you got complicated and infinite, then I won't catch it. But if you're sort of simply looping over some amount of simple, but long, but simply looping, that'll pick up right away and make it finite thereafter. Theodore is attempting to join and failing, so he will probably be here in a minute after he fails out and tries again.
yeah, I think
yeah.
if I remember right, the ML sub paper, like one of the main things that I took up after the PhD thesis was he wrote this really complicated automata minimization algorithm that took like a cyclic type and turned it into the smallest such type.
Well,
And he used that for printing the types, which is
oh
like,
yeah, a bunch of people do that.
yeah.
No, I actually have minimal cyclic types and a fancy pretty printer, because you have to have a fancy printer or you die. You can't debug yourself. But I do the minimal cyclic type thing. And that's a piece of work. But
Of a cyclic type, like a type that includes in its
definition itself. So there's two things that run around here. One of them that everyone understands and works easily. One of them causes the typing theorists like complete fits, but pragmatic typists would not be bothered. Just a funny thing. So the one that everyone knows about is, of course, I'm going to make a linked list that has an object has a next field, which is a member is a linked list, right? Okay, so that's sort of trivial, obvious. So then the other one is you apply f of f, function f of f applied to itself, which requires its first argument be a copy of itself and only calls itself recursively. This breaks the classic Hindley-Milner algorithm straight up. It breaks a lot of other folks' algorithms there who base off of Hindley-Milner. It's a very straightforward type. I don't know, I can pull up the Google Docs here. You know, f of f, I want to say is applied to itself. I don't know, what's the actual canonical form of it, but it's something stupid, and it's not this. Let me go get the short form of it because I have this in a test case here. Why do I not have? As soon as I say that, I have all things broken here. Yes, here we go. And oh, here I was a little bit off. So let me rewrite that. Okay, what is the type of this function that I just wrote in the code template body in the thing there? It's a function that takes a single argument called f and applies f to itself. Okay, what the hell type is that? Well, most typing things now blow up and they'll say it's untypable. You hit the famous occurs check in the classic Hindley-Milner algorithm. There's a thing called the occurs type, and you recursively recurge on yourself. So I turn that into a cycle. And I get a cyclic type, which says I'm a type as a function whose first argument is itself. That's the type. This causes the theory guys to throw fits. But if I look at the execution of it, of course, it just calls itself until it stack overflows, it dies. It's a stupid function. It has no interesting semantics to evaluate it other than infinite loop. It just has a cyclic type, which, like I said, breaks all the normal Hindley-Milner things. As soon as you handle cyclic types by doing sort of the obvious things with the cycle and the types, that the structure, the coding, the algorithm involved is like not otherwise harmed or changed any significant amount. So I have cyclic equals tests, and I have cyclic unification that checks that you've cycled, and then once you've cycled, it starts and says, okay, I'll tie now. I don't have to loop the cycle infinitely. I don't have to unroll infinitely. As soon as I find the cycle has been repeated on one of the other sides, I can tie to the knot and be done. So it's an extension to all of the Hindley-Milner typing algorithms, but not a big one by any means. You just throw the cycle types in, and now I can handle shit like, I did this for the global constant propagation side of things. I can handle cyclic types there as well and infer them directly. So I can find tree structures and linked list like things and functions over linked lists or functions over trees and functions over tree of shaped things and fold them up and give you a type for them. That's pretty reasonable. It's fun stuff for what you can type that way. That's for sure. You get some surprising types out.
So the question is, what happens when you apply that term to itself? Because that's when you get the lambda calculus omega term.
Yeah, when you evaluate it, it just turns into itself and it wants to be evaluated again. So it's an infinite evaluation. It's a infinite loop. It's an infinite recursion.
Right, so what's the type of that? Does it have a type?
Yeah, that's what I'm saying. I've typed it, but I use a cyclic type. It's not the standard type definition.
We
Okay.
have to separate. Go ahead.
Well, I'll pull up the type that I generate for it.
We have to
It's
separate the recursion from the type. You can still the recursive type. You can still type it.
So
But the
right, so
function
I've typed
will not
it and I threw the type into the Google Docs. It's a type of something type variable A, which is defined to be a function from A to a B, and B is a free variable because you never return B. So it's a function that returns, you don't care, it's never going to return, so it has no constraint on it at all. And the first argument is the same type as the entire function.
Okay.
So when I implement, sorry.
So I'm hearing that your type system is unsound and that it doesn't prove termination of your programs.
It doesn't prove the program terminates, the type system terminates.
Well, Alan, I think the theory you're basing that comment on is a fine theory because it holds all of its axioms hold for that theory, but it's not the only way to build a type system. In fact, it's a pretty poor way to build a type system if it can't handle this particular example.
If the type is recursive, you can say that the type is infinite. That's
Yes.
one way to describe it.
I have infinite
type-
types that way. Yes.
Yes.
I have
That you
only a
can-
bounded set of infinite types.
Mhm.
Like I don't actually have types that are non-repeating forever. Like the halting problem would require a type that is non-ever repeating as it goes off to infinity, right? Instead, these are simple, short, but repeating types. And I only find a finite number of them. If you get something more complicated, then I'll keep running and running and running, and eventually I'll not be able to type you. I
So, I mean-
believe I actually terminate though.
A simple example, though, I think that we could use as a kind of a test for the concept is, what is the type of type? Does type have a
That's a-
type?
It's type.
That's a different one.
Right, it's
That's a
type.
different
Okay, so what's the type of that?
If you have a type of the type, you are subject to the paradox, the Russell paradox. If you have a type of, if the type can include itself as the set of types, that the famous paradox with the set of all sets that does not include themselves.
Yeah,
Yes.
yeah, fine. So I don't represent types. I don't represent the type concept in the type system. There's two layers here.
So the
Or is
one way around it, you have universes of type. That's one way around this paradox. The universe 0 is a subtype of universe 1, which is a subtype of universe 3, and their infinite hierarchy of universes. So you sidestep the problem, which does not solve it.
Yeah, right. No, but to answer Cameron's question, I don't tackle that problem specifically.
If you
Well, I was
take-
aiming that more at Alan to think through based on, the axioms he's choosing for the model he's using.
Oh yeah, yeah.
if we take the linked list, it's a recursive type. Its type is infinite, but that doesn't prevent it from the type system to type it. It's
Right.
Yeah.
The type system types any infinite type that can be represented in a finite structure.
Yeah, and it says a recursive type. You can unroll it in infinite many.
Yeah, and then
times.
there's rules on unification which involve unrolling till you match the other side until you both have unrolled to the repeat point for you both, and then that unification becomes the new cycle.
Yeah.
So it's a fairly straightforward, if annoyingly difficult to go write the code for and debug all the corner cases, but it's fairly straightforward in theory. And then I believe I terminate because I do this thing where I treat the Henley-Milner side like a monotone analysis framework, same as I do the flow side. And there's a finite number of times that you can expand your term and then you're done. And I don't know how big the finite expansion is. It could, in theory, be exponential. There are test cases where you do things where they go at least cubic that I have included. And because of the hack I do for the fresh unify step, the optimizing there, they get no more than quadratic for me. They might be less than quadratic.
I think as long as C++ doesn't support recursive types and templates, we should be fine.
Exactly.
That was
Yeah, when I got a quote in a book, now it's not 20 years old, about this, where I said it's the mark of the devil because I could compute primes using error numbers out of the type template. And I was just like, okay, that's too much, guys. What is the type of a type? Well, it's a full program space. No. I want my types to have a chance of being understandable. Yep. So I mostly bowed out of C++ template typing. That's too much. All right, what else? Oh yeah, Henley-Milner things. So I do recursion in the Henley-Milner types. I do nil checking, full optimistic parametric polymorphic nil checking. You can have linked lists that are known to have all elements be nillable or not nillable or anything, or polymorphic. You can call polymorphic functions on lists that are known to be this, that, or that. I do some hacks with ground terms, so you can have ground terms with more precision than just int or float. They can be anything in my lattice. there was that's sort of the representation side. There's the optimistic computing side. The two typing theories involved feed on each other in an optimistic way. So you can type programs that neither can type alone. Oh, I type programs with error terms as long as the error term is unused. So I type unused, and if you're unused, you can be an error term, and I'll let you type. So basically, dead code can have type errors, and I don't care.
So I think we talked about this like a couple weeks ago, and I was
Yeah.
originally like, that's really annoying. But then you point out that you use that for like if defs,
Yeah, right.
basically for
That
platforms.
was the goal for that. If def Darwin, if del else if def Windows, else if def Linux. You can have type errors in the branch you don't care about, and it'll otherwise be strongly typed. I don't know how it plays out in practice. I haven't done enough of it. Like I said, I spent a year on the theory side. It's finally like, I think, stable. I'll do the fuzzing hack. That's a good one. And if it's stable, I'm going to be, declare victory. I'm off to back to implementation. All right, it's all quiet here and my coffee ran out.
I have a topic.
Yeah.
Oh, sorry, it's a simple one. Last week you said you like to use immutables. Sorry, I'm moving to the treadmill, so I'll have my camera off for a while. But you use immutables because there's some algorithms that are more efficient that way. I was curious what.
Oh, so we're talking about them here in these typing games. I frequently make new types by some construction from old types. The new type I make is almost surely one I've seen before. So I want to go hash cons them. And in sort of modern processors with garbage collection, a major performance cost is the steady doing a new allocation. And then it's immediately dead shortly thereafter, and she go do a new again. And the hidden extra cost, the actual new cost is a bump pointer. It's like half a clock or 1 clock cycle. The actual cost is you get an endless stream of cache misses because it's always new memory you've never seen before, and the memory is never in your cache since the last GC cycle. So you flood your L1 cache, your L2 caches, they get pushed, everything gets pushed out with dead stuff that immediately gets allocated, and you're foaming bandwidth out the wazoo. And this turns into integer factor speedups on all kinds of codes that I end up dealing with all the time. And the easy fix is essentially object pooling. Malloc and free, if you free something and then you malloc it right away again, it recycles in your L1 cache. So malloc and free get this behavior already baked in. So I play the games where I have my object types be immutable. I build a new one by construction from an old one. The new one is almost surely already around. So I grab an object off of a free list. I populate its fields, so none of its fields are final. I look it up in the hash table. 99.9% I get a hit, 0.1% I get a miss. On a hit, I pull the pointer out of the old one and I take the guy I filled up and I throw him back on the free list. So I don't actually do any allocation space. So this is grab a pointer from your linked list. It's a clock cycle. The thing's in L1 cache. I do a bunch of stores, which are lazy and slow and only going to hit in L1 anyhow. I then do a pass over it to compute a hash. I do a pass over to do an equals check on the hash table. These are all like 10 and 20 clocks according to the complexity of the object involved. I get a win in the hash. I throw this guy back on the free list. 40, 50 clocks later, I've got the guy I'm looking for, and lather, rinse, repeat. For this to work, of course, all my types are immutable after construction. And then it gets annoying when I want to make a cyclic type because I have to build the entire cycle of types that are involved in the cycle before I can hash and look and discover I've got a hit. And then I take the entire cycle and unwind and throw it on the free list. And of course, it's a cycle, so I have to be mutable at some point to close the cycle.
Yeah.
I pull an object off and I populate to the next, and well, I populate it except for the cycle part. Then I get the next object and I populate it pointing to the last guy, and the next one points to the last guy, and it's all recursively built till you hit the cycle. And then you're like, oh, I have to edit this guy. So it's not immutable in that sense. Then you hash, you win, you throw them back on the free list and you go forward. But things on the free list, they're immutable.
So that's
Now, three things on the hash table are immutable. Ugh.
right. In
Sorry.
other words, once you compute the hash, it needs to not change so that you can know you
Yes.
can repeat it. That's basically what it is.
Yes, and you have to be able to compute hashes on things that have
There's
cycles.
nothing to do
You
with,
have to do equals checks on things that are cycles and shit like that.
okay, because what I wondered is if was it to do with data sharing, you know, like when you transform an immutable data structure, a collection or something, you can share some of the data. And it doesn't have
Totally.
anything to do with that.
Um,
Because it's more like I can avoid doing a new on the heap because I can reuse something that's in the
yeah,
cache.
it turns out that I am also, because of this behavior, ultimately sharing everything that is shareable.
Oh yeah, you're right. You're not duplicating.
There's no duplications,
Sharing.
100% no dupes. So
Avoiding
everything that is,
duplication.
yeah, everything that's shareable is shared.
And what they were kind of doing, you know, well, no, you're not new. Well, you are newing on the cache, right? You have your own little
Once
array
you,
or something where you put things. Is that where?
I have an object pool. Yeah, right. I have a Java object pool. It's very annoying. Of course, you have one for every class. So I have dozens of Java object pools, and you have a stupid boilerplate you include on any one of these classes that's participating this way that lets them deal with having.
Oh, it's sitting there and you fill its fields. There's like, and then you so that's mutable. I see.
Right.
So that's mutable. The other guy has to not change.
Yes, the guy in the hash has to not change ever again. Right.
Okay. And he's probably the same class in Java, I suppose, like in a JVM.
Well, right.
So it's a mutable object, but you just don't mutate him after that once he's in the hash.
Yes, I can't use the final keyword.
I see. Right.
So, but he's immutable by practice or whatever, by boilerplating. So you take your steps to be careful, and you private fields, and you have
state
the right.
machine, and it's a state machine. It's a state machine, and when you start, the object state is mutable.
Yes. Yeah.
And at some point, Cliff decides to either recycle or to keep, which means make immutable.
Make immutable. Yeah.
Yeah.
And then, so he's, and the challenge is, and this is very common, definitely in OO, it's very common. Some things have natural keys. You want to look up the int 4? You know what key you make to look up the int 4?
Yeah.
Don't. You just use the 4, right?
Yeah, right. That's your key.
But
Yes.
if you want to look up a type that is a map from a list of strings
Yeah.
to a map of
The hash function is subtle and amazing, because I have to be able to hash things with them not entirely filled in if they're participating in the cycle. So one class of things, the structure class, the type struct in my plan, allows a hash to be computed that does not depend on the type of the fields that it points to. It can depend on the field names, depend on the count of fields, depend on a few other things. It cannot depend on the type, because I can't have that until after I'm done building the closed cycle, but I need it to find partial pieces along the way. So there is a computable hash and here I got crazy on the hash code, because you get bad hash code numbers out, which turn into horrific behaviors out of hash tables. Everyone gets the same hash number because they can't depend on their contents. They're only equal if their contents are equal, and unequal if they're unequal, but you can't use the hash to declare they're unequal. At least not accepting this limited set of things. So I went and looked up to these old school hash function guys who tried hard to make good hash codes, and they work. You get great hash functions out, you get great spreading up to the limits of what can be spread. And then that turns into actually pretty good behavior out of the hash table, despite the fact that you get these weird setups. Like I can't ask for the hash code of the subtype of a field member of a type struct. I want to build up a type struct's hash code. I can't ask his fields for their hash codes, because they didn't have his fields yet filled in recursively.
Yeah, the other similar challenge that I've run into in a couple different languages building compilers is when you have a concept of a type, but not all of the type information is known at that point in the compilation process.
Yeah.
So you have to be able to hand the type out to someone.
Yeah.
But it can't answer all the questions yet.
Yes, is exactly where
And
I'm at.
it's supposed to be immutable, but you continue to fill stuff in behind the scenes.
Yes, exactly where I'm at. This is exactly what goes on here. It kind of a pain in the neck to make that usable in a large scale way. Like I go through some hoops to make it behave mostly like you're thinking it should, except that periodically you can't make a cyclic type. Like all other types other than cycles are built with recursive descent, totally classic recursive descent. And it's obvious and it's easy. When you make a cyclic type, what I ended up with a coding paradigm is you basically draw one, you make a special call, and now I start a cyclic type, and here is the type I'm starting. And then you do recursive descent again.
Right.
Except that I cheat behind your back, and everything that you would have made recursive descent, I like set off to the side and accumulate them up until you declare, and I'm done making the cyclic type now. And then I take this wad and I do the cycle hack on it, and you confirm minimalization, and I do all the right things, and I hash, look it up, and come back and here's the type you got. But that you still behave like it's recursive descent everywhere, except when you start a cyclic type and when you end it. And that one, those 2 points require you to take a special, make a magic. You have to hack it in the code. Magic call to start and stop. I've not quite got it down to a try with resources, but it's probably getting pretty close. Like I've been around this path like 15 times, slowly mutating it to a cleaner and cleaner solution. I might be able to get down to a try with resources kind of thing at this point. But you still have to know that you're starting a cyclic type, which it's not too bad. I flag all the existing cyclic types. And so when you start constructing something by meeting two types, if either one of them says, and I participate in a cycle, then you have to stop. And
Right. And you have to publish it well in advance of it being constructed.
yeah,
Because it's like, because if downstream
yeah.
during recursion, it looks up that type, it has to find itself.
It has to find itself. Yes, yes, yes. This is how it works. So when you do this game, I have the intern table of things that never mutate ever again. And it is, in fact, the guys who are really fixed. I have a second table that only exists while you're doing a recursive type. And then at the end of every recursive type thing, that table gets cleaned out. And because they're recursive, they can be multiply cyclic at strongly connected components. I'm really doing standard graph theory on strongly connected components for your types. So all the rules for strongly connected component construction, equality checking, equivalence, this and that, minimization, they all apply. So a lot of that shit goes on, and you're thinking you're doing classic recursive descent type building of types, and under the hood, there's a strongly connected components algorithm running and all kinds of other crap going on. It was kind of a pain in the butt, but these parts are like, the theory behind them, like strongly connected components, that's all well understood 40-year-old theory. Once you built them, they weren't part of the difficulty of building and thinking about cyclic types. You had to do that step. It was a big chunk of work, but then like you just depend on it. Hey, I can handle a cyclic type now, and it was just, you know, one more thing. Yeah. So immutability. That was Bill's question originally. Yes,
Yeah.
I do it for perfect sharing. I do it for performance.
That was one use case, I guess.
Yeah, right.
And then what did you
And this particular case, I'm not using immutability for concurrent algorithms, but I
Right.
also do those as well.
Okay, so that one is safely published. Once it's safely published, it's simpler to do.
Yes, right,
Runty.
right.
So that's one use case too, I suppose.
Yeah, yeah.
And then
These are almost, well, that's not fair. Okay. The ones for performance and ones for simplicity of writing the algorithm.
okay.
And the sharing one is actually it is about performance as well, because I do a whole ton of equivalency checking of things. As I make a type, I do an equivalency check. Is it equal to another type? I do a lot of equivalency checking, it turns out. I do mins and max and meets and joins. And the first thing you do is these two types are the same, so the max of them is the same. And shit like that goes on. And as soon as you're completely immutable and hash cons, the equivalency test turns into a 1 clock pointer check. So that's a performance hack as well. And C2 in the land of Java does this all the time. That's a main speed hack on the core guts of that compiler. He doesn't do cyclic types. That didn't have that theory worked out that back then, but he totally does immutable sharing of all the types. I give up on cycles and just get really conservative really quick. But if you're not a cycle, it's, hash cons, basically with these days, you call it persistent data structures kind of thing.
Oh, they're just interned, if you will.
They're interned, yeah.
So Bill, are you still working on Scala stuff?
Yeah, mostly, yeah. Scala 3 came out and anyway, yeah, that's sort of what I'm doing. Yeah.
And they need a book?
Yeah, there is a book. I already did a book, so I had to update it. But it's a big update. It's it's kind of like Python 2 to Python 3, like a big jump. So I think people are quite hesitant to upgrade until someone else does.
So what's sort of more excitingly new about it?
Well, there's all kinds of stuff. So one big thing was they had metaprogramming marked as experimental in Scala 2 for 15 years, and
15
everybody used it.
experimental. Yeah.
So then they have something that's not experimental anymore, that's completely different. So everybody had to rewrite that part of their stuff. They have a new, this is like Surface, but it's a new syntax that's indentation based rather than curly braces.
Oh,
That was like a,
I hate those.
not necessary, but it supports the other one as well. So I think that just mentally gives people the feeling that there's a big leap.
Yeah. Oh, I bet.
But there's things that were tightened, like things that were fixed that really are broken. But I think the difference between Python and Scala is that Scala has types, so you can rewrite things predictably and provably correct more than in the case of Python. But Python, it took 10 years, I think. That was my impression anyway, for people to mostly move over.
I would argue that implicit givens are really not the step in the right direction. There was no point of breaking them up and renaming them. So you have 4 more concepts to learn which one to use. I strongly believe that could have been avoided, but it's already done.
I think there's also a proof out there that says that all Python developers still have 2.7.3 somewhere on their machine, and all Java developers still have Java 8 somewhere, right, Mark?
True for both of those for me.
I'm on Java 8. So I'm on
I
Java
moved
8.
AA to 15. I might yet go to 16 because there's
No,
some of the syntax
Go to
hacks are
17.
nice.
Go to 17.
Go to
Don't-
17, huh?
So-
But are you using it, or you're just running on
No,
newer
so
Java?
the only version
I'm
of
using
Java that exists besides 8 is 17.
Oh, I
That's the way to
see.
think about it.
That's a good
7
point. Okay, fine.
because it's a long-term release,
Yeah.
right? So even though it's the latest release, it's actually going to be by some definition, the most stable and predictable.
Yeah, it's the next long-term release. Okay.
I don't
it
know.
has to-
Since
Arthur-
since 8? Is it
What do you
every 9 releases is a
Well, the old model was that you went from 1 to 2 and 2 to 3 every 5 years. And the new model is the long-term releases are 5 years apart. Also, still, they just numbered 8, 9, 10 twice a year. And,
it is weird. You like look away for a minute and you come back and Java's 4 versions further along.
Yes. And they're all like dirt cheap, minor, like what the fuck? And of course, I don't want anything to do with modules and sealing. That's just like, what the hell, guys?
I'm
it's
still
a-
confused at what are the main lines of Java.
Oh.
From 15 to 16 to the modules, without the modules, the experimental, the not experimental.
Oh.
It's a nice model that they have though. It's the train depot model, right?
Yeah.
After 6 months, whatever's done, tested, and in goes
Yeah,
out the door as a release.
I
You know,
approve of the model, honestly. Yeah, this shit's been hanging
It's
around.
okay.
Used to be
That's
shit
cool.
would hang around for a next release forever and a fucking day.
Right.
And now minor shit that's unrelated just gets out the door and goes on.
And the worst part is if you have that old model where you're waiting on a feature to show up before you ship, like we are going to ship this thing with modularity. Okay, so we're never shipping Java again because we can't friggin' finish this modularity thing, right?
Yeah, right.
Took them
exactly.
10 years to get that release out, right?
Yes.
And instead now it's like, oh, and the worst part of that is that everyone who wanted to get something into that next release, when they saw it was getting ripe, they're like, well, I'm not waiting another 10 years to get this in. So I'm going to put my half-done Java feature into that release,
Right.
push it out the door and fix it later.
Right.
And,
And
it's
then
like everyone downstream is getting pissed in the stream. And it's like, this is bad.
right. Yeah, right. This is like, oh, all these half-done things showed up in the release. It's not ready now.
Right.
That was a
So that's
self-feeding defeative cycle. It was a
So
negative.
if you know the longest you have to wait is 6 months for your thing to go out the door,
Yeah.
It's much less traumatic.
It's much less, it doesn't even matter if it's 6 months, you just know that it will go out the door in a finite amount of time. You can look up on a fucking calendar. Makes a huge difference. You get it ready when it's ready, you add the padding factor, then that goes out, fine. There's
But
no
as we
rush
said,
to
the-
half bake it out.
The halfly baked feature still could make it.
No, I know, but the general population of people writing features are not rushing to get on the once a decade train, which forces the decade to go out another decade. It was like ludicrous. I totally approve of the current strategy. Yes.
Mhm, mhm. Yeah,
And then somebody asked, what am I doing with things past 8? I'm using the fun syntax. Switch statements got a bunch of pattern match things that are useful. And the jump from 15 to 17 will be because I want to pick up the instance of naming hack. I use that pattern all over the place, and it'll hit 1,000 places in the code. And IntelliJ, finds them and says, should I do this? And you could just hit the fix it button, and a lot of it, just will come in. So I'm theorizing, just makes the code look prettier. I used, I think the push from 8 to 12 or 13 was because Marco Civetto, the guy who did a bunch of my evil test cases, was writing bigger and bigger and bigger things, and we're writing them as Java strings, broken line by line by line. He wanted to have the big string thing. So I finally bit the bullet, did the big string thing to get better test casing done, which worked fine. So it was, I don't make heavy use of the new
You're talking
features, but some.
the triple quote thing.
The triple quote thing, yeah. Some of the test cases get bigger and uglier. Like I said, he was doing full-on piano arithmetic, doing abstract multiply divide and piano math and typing system. And this should all type. And fuck it, took a while, but it does now. You can look at the code and say that should type, and then you stare hard at what it's trying to do. It's like, that should type. And then you can look at the types you get out, and you're like, yeah, I guess it's correct. Oh God, it hurts, it hurts. But there it is. So your piano math's already a weird thing.
So you're done almost integrating the constant propagation in the typing with the Hindley.
I am done integrating constant propagation in Hindley-Milner. That was the goal. That was the win this last week. I've like some weeks ago, oh yeah. Bye,
Cool.
Dan.
Congratulations.
I got a lot more serious. I've been flipping on and off like the combined algorithm and finding bugs left and right and playing whack-a-mole for a while. And I finally said, I'll just make the damn test run just GCP, just Hindley-Milner, and then just the combined, and do them all every time. Immediately found a bunch of things I had broken in GCP without realizing it, and went back and fixed them. Hindley-Milner alone is a very straightforward algorithm. I found and fixed some things. So that went around. Then I was realized, okay, let me change the seed, see what happens. So I changed the seed manually for 3 months. And every time I changed the seed, I would get a different bug. And then I played whack-a-mole as I went back to the old seeds. I finally said, okay, run 4 seeds. Oh, okay, that took me like 2.5 weeks, all 3 modes of thick guys times 4 seeds. And I got bugs out. And I said, okay, I hate to do it myself, but I got 2, and I doubled the seed count. And then that took me like 2 more weeks. And then I doubled the seed count again, and I found 3 more bugs that took half a day. And I doubled the seed count again. I found 1 more bug. Both of them, all the bugs were in minor variations of the thing I didn't quite have tweaked just right. And I doubled again, got nothing. And at this point, it takes like an hour to run the fucking test case instead of seconds, because I'm running so many variations with, these are all done with cubic and quartic runtimes, because the assert's doing whole program, small step asserts, and got nothing. And then that was my victory declare. So I had an exponential drop off on bugs with a exponential growth in testing volume. And at some point I declared doubling and getting 0 out was, done. But the fuzzing's a good one, so I'll pick up fuzzing here.
Fuzzing is a pretty must-have in these cases.
I'm thinking I was going to fuzz definitely for AA, at least for the grammar checking side of things. I haven't seen AA grammar bugs in a while, but I don't have enough test cases to prove that I don't have grammar bugs in there. I did take the grammar and throw it at one of these grammar checkers, and had it declare reasonable.
I don't know about fuzzing, but what you could do is write a thing that generates programs from the grammar.
That's the fuzzer.
Oh,
That's what a
fuzzers
fuzzer
I've
is.
always heard of as like generating random stuff.
Oh no, they have
Yeah.
more and less smarts and dumbnesses about them.
That's neat.
You
It
can,
tries to exploit the grammar to come up with a case that.
they're totally guys
you
who
can-
play the grammar. Yeah, walk the grammar,
Mhm.
do things. Yep.
And there are various ways to do that. You can generate using a grammar, or you can mutate an existing, like you take the existing corpus, like existing tests, and mutate them.
I've seen that too, which I don't have big enough test cases for that to matter. But I assume. Oh, here's Matt's trying to say something in chat. Let me bring chat up here.
Can you put that in the Google Doc, Matt?
Yeah, put it in the Google Doc. Actually, I haven't looked in the Google Doc in a while. Yeah. Pink blobs. I'll have to go look up this one. Whose is this one? I've seen a bunch of these readings. Oh, these are readings on books. Yeah, I'm hoping to pick up some of these tools. I know these tools float around. Fuzzing with grammars. All right, I will stare. I bet you from somewhere in here I'll be able to go get. Oh, and here's okay. I can get a I'll get a code out of this. I won't have any trouble finding a fuzzer. Hey, we're on.
The other cool approach is Kava really does it really well. It have a 3 categories of tests: the positive tests, the ones that should pass,
Yeah.
the typer, the checker, the negative test that one shouldn't pass. The third category I can't remember now, but I remember they were 3.
You definitely have tests whose expected answer is an error. Like let's see here. Let me find a better one. Wow, this kind of shit. Let me find CCC. Yeah, some sort of crap like that. They have a lot of variations on these kind of themes floating around. Cannot unify basically a float and an empty struct. Here's the case that requires the combined algorithm to type and give you an error term if you just do Hindley-Milner or this one. Actually, the error is cannot unify and the empty struct. And that's tested before. Like I have a bunch of these, including ones that I allow broken parts in the middle, and you get back a Hindley-Milner term which has an error in the middle and a flow term which is totally fine. But the Hindley-Milner term can also acknowledge that the error in the middle is unreachable. What's it going to do? This other guy. This other guy's pretty ugly. Oh, throw him in. What the hell? Let's see here. We have a bad line break. So it's a loop that passes in a string to the id function and a number, and decides you're going to get a number or a string. And if you know you're only going to get a string, then you only going to get a string, and then he's all good. And otherwise, he thinks he's going to get a number and a string, and he complains he can't unify numbers and strings. So I'll let somebody's trying to hack the good, like Google Docs doesn't have a code writing thing. It's just like, this is the obvious thing for doing here. Why are they not having?
And they hold software engineering interviews in Google Docs, and you write your stuff in Times New Roman, and it's fantastic.
If we keep complaining, they will build one.
Why would you interview at Google?
I was a young undergrad, and I wanted a job building compilers, and they were one of the shops.
Yeah. There's a few enough people that do compilers for serious. You get LinkedIn, you get Microsoft, you get who's the other guy? I want to say the Apple, obviously. Mozilla folks somebody does JavaScript funny. There's a couple. Oh, the Node.js folks are a standalone group.
Facebook does.
Facebook, that was the other big one I was trying to get at. Yeah, Facebook.
It seems that there is a renaissance in computer languages.
You know,
In the last 3, 4, 5 years, there pop a bunch of them.
yeah, Java's quite old, and I think Brian Getz has done a great job of shepherding it on and keeping it sort of strong. And it's, it's still approaching what I would claim to be sort of the useful end of life for new kinds of things.
No one is better at saying no than Brian Getz.
Yeah, and I think that's important.
And that's not an insult. That's a huge compliment.
Yeah, yeah.
Because it is so easy to add crap to a language.
Yes.
And with a language like Java, like look at the modularity stuff where it tripped up. I mean, the main thing was they were trying to take horrible things out of the language and, like unsafe and whatnot. And they broke everything on every little move. It was tough.
Yeah. Yeah. They didn't take unsafe out, apparently. I'm still using it.
Yeah. Well.
Yeah. The big fail there in my head is they didn't have a CAS. 99% of my unsafe uses are CAS. The other 1% are unpacking deserialized structures into final fields. I do code gen to write bytecodes that store bits into final fields for part of deserializing.
So I can't remember. Did they make atomic field updater? Is that still?
It's there. It's just it has performance issues over.
They got rid of the performance issues.
Did they?
Yeah, is it unsafe? Is it unsafe though?
No.
Okay.
Atomic field updaters are like var handles are the official cool way to do it now, but they fixed the performance issue with atomic field updaters when they put var handles in. So they're almost free anyway, and they seem, I don't know, they're easier to use than var handles are weird. But
Yes.
I love the field updaters. I use them constantly.
Okay, fine. When I don't care, I grab the field updaters. When I care, I do the old unsafe things. And non-blocking hash map hasn't moved in a while, so it's
So
still
field
using.
updaters are way faster than the old unsafe way because you only do the lookup once.
I'm sorry. The
Field
old
updaters,
unsafe thing does the minimal machine code instructions possible here. I don't know how you can get any faster than the one CAS instruction. I'm missing here.
Yeah, you cache the offset, right? Is that what you're talking about, Cam?
Yeah.
that's what I'm talking about. Yeah.
Yeah. At start time of at class seal init for non-blocking hash map, he asks the question about the offsets and they're cached. Then I do effectively a field updater manually inline because that wasn't possible back in the day. That just
Right.
grabs
But I
the
think it's
constant fields.
intensified now. So if you have a static field updater, it's just as fast as if you wrote the CAS in C.
Right. That was the question. It wasn't for a long time. And so when they first came out, I turned around and turned them on and lo and behold, took a giant perfit and turned them off and said, no, go back to the old shit. Fix your bugs, guys. And maybe they have now.
If only someone knew how to work with that code.
Really? No kidding. It's been steadily improved on for the last umpteen years. It's slow going, but so is LLVM.
Yeah. Now we have what, 3 or 4 different pauseless garbage collectors, right, Arthur? Like we've got
Probably.
Shenandoah.
The VGC, Shenandoah, and C4.
Yeah. Pretty amazing. What's really amazing is that, with 99% of the code being written today being in JavaScript, Java has still stayed at pretty close to the front of that curve.
Yeah.
Right. In
I
terms
don't
of
think that's actually true, or at least the last time I looked, it wasn't that long ago. Like C and Java and JavaScript are like still kind of banging it out.
you're talking TOB, right?
Yeah.
That's really warped. I mean, the simple reality is every website has about 400 megabytes of
Yeah, but how much of that is
JavaScript
new?
code.
How much just cached and downloaded yet again?
Well, it's downloaded, it's cached, but then it's slightly modified and downloaded again and slightly modified. So it's not. There's only been 4 lines of JavaScript ever written from scratch.
Right. That's what I'm saying.
But it's an evolving organism. So it's like
Alright.
JavaScript is now our Omicron variant of language.
Yes, right.
You can't prove that more than 400 lines of JavaScript have ever been written. I don't believe it. That's a conspiracy theory.
I believe the big companies are long move with writing JavaScript, but then using it just for the platform.
That's what big tech
Yeah.
wants you to think.
No.
It's also impossible to tell the difference between well-written JavaScript and fuzzed created JavaScript. So
That was
No,
my
I mean-
experience.
Using a language to translate to JavaScript, not writing JavaScript directly.
A lot of folks
Using
translate to
JavaScript as the-
JavaScript too.
Yeah. Using JavaScript just as the platform, not as
Yeah, right.
writing.
To run on a browser. Yeah, right.
to be fair to JavaScript, though, it is probably the best looking language that was ever written in 10 days.
Yeah. The guy did a good job for
Yeah, for 10 days. I mean, it's
for the
awesome. I
time
couldn't
constraints,
do
pretty
that in a year.
Yeah. No qualms about that. Yes, I love to hate JavaScript. It works, but I want my types. So fine. My son here
Yeah,
is
so always
doing
types.
a lot of C code now and doesn't like Java too much. And he has to do a lot of JavaScript. And boy, he hates the no typing thing. And it ran a while and none is not a function. And you're like, oh, fuck. What broke now?
I
And how do
haven't
I
asked
debug
it for a while. Bill, can I ask you a question?
Yes.
Yes.
Yeah.
What is the type?
You're asking me?
Yeah.
The Scala guy.
What is a type? Well, I know it when I see it.
So say it's Supreme Court. Yes.
Correct.
Yeah,
Correct.
yeah, I'll get back to you on that. That's funny that I didn't realize I would have a hard time answering that question because I do think about them a lot.
Cameron has a blog about it.
No,
I
okay.
have
cool.
and I have my
It's cool.
strong opinion on them as well. They're not too far apart, but different people, yeah, go different places for sure. You should think about it because having a short, fast answer there will totally strengthen your concept of what it means. Right. By the time you nail down what you really think is going on there,
Mhm.
you'll have a better understanding. What is this? Oh. All right, Max, you should totally say that out loud.
So I said the texted Cliff, that's got to be the title of this video. What is a type? I know it when I see it.
I think
Because types are obscene.
I can totally. Speaking as a guy who wrote the golden answer for the piano test cases, holy fucking get obscene.
I can try to paraphrase the one used for the words. A type shall be known by the type variables company keeps. There was a quote, you shall know a word by the company it keeps. So
Yes.
I believe it's applied to a type.
Yeah.
Well, the simple answer is that a type is a set. And so then the question is, what is your universe of values? And then you've defined all your types.
Okay, and we go to the Russell again. We knock on his door. And the Russell paradox exactly represents if you treat the types as a set.
So actually, there's a way around the Russell paradox. There's a whole different kind of type theory called new foundations. And so there's a Wikipedia page on it.
Throw it in the links.
Paste it, yeah.
Yeah, I want to see.
Yeah. I said it earlier, the universes are one way to sidestep the problem.
Yeah. And so like new foundations, it has a universal set, which is what you want for programming. And it doesn't have Russell's paradox. And the reason it doesn't have Russell's paradox is because you can't talk about the certain kinds of sets, namely the sets that cause Russell's paradox. And so it's like, it's actually very easy to implement. And I haven't implemented it, but like the hard part is devising a proof theory for it. But
Yeah.
like in terms of
The pecan pie is getting on. I mean, it's good, but I support cookie making.
yeah, so
Sorry.
like I was talking with another guy, he'd implemented like the stratified version, like the type theory TST on it. And so like new foundations is you take the type theory TST and you drop all the indexes. And so like I haven't figured out how to do that.
I'll have to stare at this and see where I fit. Like I do these infinite types, which means they have not descending chains. They have infinite chains of limited complexity as members in the set. Right? So any finite structure I can use that has a cycle inside of it, and it's infinite unrolled, so you only get these common repeating patterns.
The closest thing I have come to think about a type is that they're multidimensional. The type can contain other types in itself, so it can somehow you have to express recursion somehow.
Yeah.
The type can be a part of some other types. That's the sum type and the other kind, the sum and the product types.
Yeah.
And types can be values, and this strange mix have to somehow represent the type.
Yeah, fundamentally, type is something that allows you to express and enforce some combination of constraints and capabilities, and that's really all it is. So, you know, we come at it like blind mice on an elephant, right?
Yeah.
And you know, someone's like, oh no, it's names are types, right? So
Yes.
nominal typing, and someone else is like, no, it's, you know, fields, it's structural typing, right? So we're all feeling up the poor
yeah.
elephant.
They are all correct and they're all wrong. There are certain kind
Yeah, I don't claim
to
they're all
look at it.
wrong, but maybe they're all
Well, there,
right. Yeah.
I would say that any,
Types are different things to different people.
and not only that, two
Yeah.
type systems, like what Alan and I were kind of joking about earlier, like two type systems can be absolutely correct and completely looking at from one to the other can be completely wrong, right? Because the type system has to be internally consistent.
Yes.
It doesn't have to be universally consistent.
It
you know
doesn't
what I
have to be a mapping, a one-to-one
Yeah.
mapping between your types and Alan's types. Yes.
mean? Right. For example,
And in particular, I'm trying to gather everything that Hindley Miller does, plus a bunch of other stuff. So there's not a one-to-one mapping. I have some types that classic Hindley Miller will not represent.
right.
We'll just claim type error.
And Hindley Miller is not wrong. It's not broken. It
That's
just,
correct.
its axioms don't support those concepts.
Yep. Yep.
So it's internally consistent. It's correct by its own definition of the universe.
Yeah. Okay. So there's a go. So I'm defining a type as a set of values. I want my type system to be closed under certain operations. So I only get other sets of values that I get from other types by doing these things. I can't ever step outside the bounds.
Okay. How about the sum type or the product type? The sum type is a type that one can be many, and it's one of the many types can be.
Right. So I specifically don't include union types. Right, but I have a stronger notion of subtyping.
Right, but they're still countable, even if you do
Yes.
include, they're still countable, even if you do include union.
And I can take the standard union type things and do tagged unions with them, which is sort of a nearby concept, but not 100% the same. But I'm not doing union types. And I actually went there on purpose because I don't like the runtimes of those algorithms. So there is another theory of a type theory that's totally self-consistent. In fact, the paper that I did stared at for a long time, did a lot of stuff with. That's I'll throw the link in. I think I still got it up here. It's ML sub. It's subtyping. He's got a lot of cool concepts, but he ends up going to constraint theory for proving. He allows union types, goes to constraint theory, my experience with constraint theory typing is it can get ugly fast in terms of performance, and so I didn't want to go there. So I wanted a stronger performance bound, and you know, went after it a different way to get there. You know, you could argue that he might get good bounds anyhow, in which case his type systems is fine. And you know, maybe I could have based off of that theory and extended it the way I wanted to extend it for, you know, dead types and shit like that, and had it all work out. I got stymied. Here goes for Bill. I got stymied because I can't do Scala on Windows. I go down, hit the download Scala on Windows here button, and it gets halfway through and then it hangs. And it hangs in the same place it's hanging for a long time. And there's been open bugs, closed and open and closed and open for hanging here, having to do with some random internal part that I don't remember the name of now. If you said the name, I would point my finger at you and say yes. But there's some internal thing that has to do with nothing that gets called on Windows version X and beyond. It hangs instead of returning, because it's doing some sort of checking of accessibility or admin rights or something. I don't know what. Anyhow, it hangs. So I get a silent hang whenever I install Scala. And I installed it from like 5 layers. Like I did it from IntelliJ, it hangs, and I did it from somebody's do this and hangs. And they said, oh, you have to have this Savannah or Capybara, I don't know what the hell thing was underneath. And this guy does the right thing, and that's the hang guy, and sure enough, it hangs. And I finally downloaded it manually with wget and everything else, and ran the install tool, and it hangs. And so I can't
Unfortunate.
install Scala on Windows.
That's unfortunate.
Yes. And that stopped me from doing ML sub. It's like, suck. I'd have gone after ML sub and said, maybe I can make this work and extend it. I don't know what the performance of these, you know, I've heard the performance of constraint-based systems get ugly. Oh, the readability of them gets really ugly.
Do you mean the simple sub or the ML sub? The ML sub is
Simple sub. Simple sub. I looked hard at it. ML sub disappeared. I looked hard at the polarizing types. I was with you on that one, that they didn't describe anything hugely obnoxiously good or bad. I went back to ML sub and back and forth between the two and decided that I was already like mostly there. Yeah, I haven't tried to Linux. I have to put it under the Linux. Oh, under virtual machine on Linux. No, Matt, I did not. I have not set up a virtual machine on my Windows box in forever and a day. And maybe
You don't have to now, because the new version of Windows is actually, this is the year of Linux on the desktop. It has 2 copies of Linux in the new Windows.
New Windows being 10 or 11.
Whatever number they have.
Microsoft's pushing 11 at me, and I don't want it. It's fine.
Yeah, they actually have 2 entire Linuxes in there. One for the shell, and I don't know. I'm not a Windows user, so
Yeah. Okay.
Windows subsystem for Linux.
that's
Yeah.
yep. Windows subsystem for Linux, and there's another copy of Linux hidden in there as well.
Interesting. Yeah, I knew they were shipping with it. I hadn't. I mean, I just didn't want to try and screw around with a virtual machine to go down a theory side of things that I wasn't sure I was going to use anyhow.
But you know, who would have thought that we would have lived long enough that this is actually the year of Linux on the desktop, and it took Microsoft to get it there.
Microsoft, this is a huge move against the Linux to allow the Linux program to run on Microsoft. Without, I have read that the performance is little than 10% of the original speed it executes.
Can you run Wine on it?
Wine on the
And-
Windows, on the
Is that
WSL.
WHINE.
No.
the-
Windows
Wine is
emulator.
the Windows emulation layer for Linux.
Yeah, I know.
Oh, why? Yeah.
Because if you could, then you could run Windows games on Windows.
That would
Yes.
be pretty cool.
Yes. I'm still a big Windows fan for being a big Windows gamer. Nothing to do with Windows to OS.
Yeah. No, that's why I have Windows. I have a couple very nice Windows machines, and all they do is run
Run games.
Yeah.
Yes.
one
Yes.
game.
Yep.
What games? What games?
What's that?
What kind of games do you play?
Oh, all sorts. Actually, I recently got Half-Life Alyx for the VR stuff. Unfortunately, it's been crashing, and I'm not the only one who has this, but it crashes every time I run Alyx because of the something to do with NVIDIA. I have a Titan video card, and it crashes.
What a coincidence! My video card may be fried. That's why I didn't come on time. I'm running somehow. Right now, I have both monitors that run in mirror mode. So one is useless. I can throw it away now.
All right.
I have.
Yeah.
Okay.
Ah, oh, interesting. Yes, I play a lot of first-person shooters. I play a lot of Civ 6, Civ 2, 3, 4, 5, 6.
Is 6 playable now?
Oh, it's very playable. It's been
That
playable
was,
for
that was the shittiest release of a game ever.
it's been
when it
playable
first
for
came
at
out.
least a year.
Okay,
Maybe-
I'll try it again.
I'll agree with you. I did not like the starter. I went back to Civ 5 for quite a while before I went back to 6. The graphics are better. The gameplay is pretty well integratable. I mean, it kind of makes sense now.
Here's a suggestion for a game that if you look at it, you'll never think you'll like it, but
Oh.
you should try it. Are you ready? It's an
Uh-oh.
old one. It's called To the Moon.
Excellent. Well, we should put it in the chat. You know, what do people do? Not chat, the
All right.
docs. Max, you can put your
But it's,
docs
I
it's,
in
a
can
there.
weird, it's a
suggest
weird
one.
one. I didn't think I'd like it, but I really liked it.
Caves of
Have
Blood.
anyone played the World of Goo? It's,
We got all different games now. It's just funny.
Hmm.
Where did my web?
Generals is the only game I've played in like the last 10 years
Oh,
because it's online, loads fast, and it's just like I played with a group of friends. It's multiplayer, and it's like a sort of tower defense, fog of war,
Oh,
like
yeah.
control the map kind of thing. And it's a lot of
Yeah.
fun.
I've done a lot of tower defense things. They come and go. They're like mindless, dumb, fun things.
I don't know if I'd call this one mindless. It's a
Well,
lot
no,
of
as
fun.
soon as you're
though.
multiplayer, it's not mindless, but
Yeah, exactly.
right. Stellaris, play
I'm still trying to make it through the Turing test, and obviously I'm not succeeding.
Stellaris. Yeah.
Have you played that one? Turing test?
no.
What was Matthew? What was your current favorite mindless game? Boba. Baba is you. Holy crap, that's a mind game.
What is you? How do you
Baba
spell
is
it?
you. Yeah. Let me go see if I can go add Baba is you. Yeah, you have to play the first few levels to understand the mind fuck going on there.
It gets worse like every 30 seconds.
Yeah, right, and they ramp up. It's a puzzle, turn-based puzzle game. So it's, but oh man, does it mess with your head? That's a fun one. So games that mess with your head is puzzle-based games. I do those. My son played what, the Fez guy.
Fez is also fun, but also mind breaking.
Oh, okay. Well, there you go. Pliers. I can try, but then if it doesn't work, it's pliers time.
And I did pick up a week or two ago, I picked up a new Atari 2600.
Yeah. Wow.
I didn't realize that Mario Brothers was an Atari
Did
2600.
you camp outside the store to get it?
I can't get a grip on it. It needs I can put more torque that my fingers can get apply grip.
So I have a collection of old Atari 2600s and almost every game they ever made.
What you can see behind me, so if I can get my pen here, TV is only ever used to play games. And here's the current Switch, Wii U. Here's 2 Wiis up here. There was an Xbox forever. I think I got rid of it finally. What's the black thing, Matthew? Is that the Wii U?
Probably.
So there's like Wii's, Wii U's, Switches, but also Xbox, also something else.
I love the Wii U. I mean, it's the best $20 game machine I ever had.
Which one?
The Wii U.
The Wii U. Yeah. Yeah.
They sold so poorly, they like dumped them for almost nothing.
Really? I don't know. My kids love the Nintendo game series for every day.
Oh yeah, no.
Chiphead. Oh, I think I played Chiphead. Yeah, I think I've played Chiphead. I used to play Core Wars for a little while. But we're talking 40 years ago. Mindless. And of course I played, the Adventure, and I played the very early Civ flavored things that were Empire. whatever, you marched your tanks out and captured things and made cities and made more tanks and explored a randomly generated map. All right. Clearly we've gotten off topic. Is anyone want to bring us back on topic, or I'm going to declare victory since there's a large kitchen effort going on behind me?
I'll talk about my inliner next week.
Oh, awesome. I would love to talk about inliners.
It's a little late
cool.
for me. I've got a meeting in 20 minutes.
Okay. And Bill, you're about to say something.
I just had another quick question about last week. You said that the previous week, which was Thanksgiving, so you meant the previous one, I think. Cameron was talking about how he puts things on multiple heaps. So I
Yeah.
went back and listened, and I don't think he ever said that. So I don't know. I couldn't find it anyway. So I was just curious what that was about. If it's quick.
You want me to explain that? Yeah.
Yeah.
So we didn't set out to reproduce an Erlang-like language runtime, but that's kind of where we ended up, where, in Erlang, you have this concept of a process, and it's like a small talk object, and that you send messages to it and it does its processing there. And it's somewhat loosely coupled to the rest of the running system so that you can kill it or some group of its without taking down the whole system. And this is how they do the routers and switches and whatnot, where they want, if you have code running against a packet and it blows up, you don't want that to take out any other code running against any other packet. So it allows, long in advance of having a multi-core chip and having hardware threads, they had the ability to kind of emulate that. You could think of it like green threads. So each Erlang process was an object that had its own thread, kind of. So we ended up there through a different route that brought us there for a different set of reasons, but a very similar design, in that we have what we think of as spheres of mutability, meaning there's a space within which mutability can occur, and outside of that space, you can only interact with that space conceptually through messages, right? So if you want a value that's in that space, you have to send a message that says, give me the value. Think of it like, as bad as an accessor on a property type thing, but done as a potentially asynchronous message, and and so on and so forth. So that sphere of mutability is what we call a service, and because all of the mutability is within that sphere, and nothing else is allowed to even look at data in there without sending a message in, that sphere can be its own, in a Java sense, a VM, right? It can be its own machine abstraction, and as such, it can have its own memory management. Now, these different spheres, these services, they communicate to each other. They can only pass two different things among themselves, right? They can pass immutable values, and they can pass references to other services. So the only things that can permeate the boundary of the sphere are immutable values and proxies to services. So mailbox proxies, if you will, to use the concept from Erlang. So the benefit of that is that all the memory management can be hidden inside each sphere, but the downside is that I'm now copying immutable data among these, right? Which would be like, if I'm passing immutable data back and forth, I have to move it into that sphere for it to look at it, right? Which would be awful. But the design, these spheres aren't just globally floating out there. They're actually within containers, and a container is actually itself a service. So a container represents a collection or a set or whatever you have a hierarchy of containers, and each container can have its own immutable memory area, because immutable memory areas can be compacted asynchronously without halting, right? Without pausing, without stopping the world, right? So go back to like the JRocket garbage collector, for example, and that's how they did it.
So the immutable one can be compacted without stopping, because you can have two copies of the same.
That's right, because you can copy compact, and then as the number of subscribers to that space decrements as they find out that there's a new space that it's copy compacted into. When it hits zero, whoever drops it to zero can actually just throw away the old space. But in the meantime, you'll have two or even more if there are multiple generations of copy compaction going on. You could have multiple copies of the same immutable data. So basically what that means is that instead of copying immutable data among services, when you have immutable data, you can just put it into this shared immutable space and then reference it via that.
You do about equality checks.
That makes sense.
Come on,
Quality checks on immutables are easy.
including when it's mid-copy and you have versions and left and right, and I got a copy from here and I got a copy from that one because you're mid GC cycle and I want to compare them with a pointer equality type.
Well,
of check.
pointer equality would be an optimization. So a pointer equality will tell you true, but it can't tell you false.
Okay, so there's no identity.
No, the identity is the bytes. That's the point. So it's the identity isn't the pointer. The pointer is the hash optimization, if you will. So I can compare two pointers. If they're equal, then the value is equal.
Yeah.
If
Okay.
they're not equal, then I can compare two regions.
Okay,
And
so
that's
here
the-
you're doing value equality and not reference equality.
Conceptually, it is value. Yes, correct.
Okay, is there any way to do a reference equality? Like I use a reference equality exactly in my hash cons and games,
As an optimization, yes. So within a generation,
but the language spec does not say.
oh, none of this is in the language spec. None of this is visible. This is all internal optimization.
So when the
Yeah.
when the language at the language level, if I say I got a thing, I got another thing, I want to know, are they pointer equals or reference equals? Can I express that in the language?
Yes, but it's not strictly pointer equals because there's no visible pointer. So what we have is identity equality.
Okay,
Um,
so I do
I
an.
showed you this once. I can
Yeah.
share it if you let
There's
me.
I understand that you have typings help as well, but I'm asking two things the same type. That's not the problem. It's, are they identity equal as opposed to value equals?
So the way I'll explain it in the conceptual terms first, because that's what the language does in its runtime, CMAX. So if I have an object A and an object B, or really a reference A and a reference B,
Yeah.
I say I can get the underlying reference object itself for A and the underlying reference object for B. So think of that as a pointer, but it's not a pointer. It's a, if you will, it's a boxed pointer. I don't know how to explain.
Okay.
But now I have a reference to A and a reference to B, and I can say, are those references equal? And the way that reference equality is implemented is the reference gets the identity of the reference, and the other reference gets its identity, and we compare the identities. And
Okay.
the identities are opaque on purpose because we don't want you to know what's going on under the covers. But yes, it ends up being in most cases a pointer equality check.
Okay. And how does it pass or fail when you're doing copying of immutable structures and you've
Right.
got two copies floating around? It's a classic
And-
read barrier problem in
Right.
garbage function.
It's not a read barrier problem in this case because we're not moving those immutable objects. They stay in place
Yeah.
until no one is looking at them. And
Yeah,
then
I
when
get
no
that.
one is looking at them, they can disappear.
That's not the issue.
Okay,
Issue,
go
you
ahead.
have two of them
Right,
and you want to claim that they're actually the same.
right. But it's easy to have two of them because I can say, for example, with an integer, I can create a new integer object.
Right.
All integers are objects, of course. They may not
This is
have memory, but they're all objects.
This is
And
not
I
the
can give
problem.
it, I can give it a bit pattern of 1001, 42.
Yeah.
Right.
You're talking about value equivalence. I'm saying for whatever reason, I want to do identity equality check specifically because I want to implement hash consing as a performance hack. And actually I have cyclic structures. If you fail to hash cons, you will infinitely recurse and you will never terminate. It's a bug to not be value equivalent. So I need value equivalence. So I need to know how is it possible to express this in the language?
It is not possible to explicitly express pointer equality in the language.
Okay, how do you do hash consing like things? How do the hash consing like behaviors?
Well, you compare the identities of two objects and under the hood, it will do pointer equality.
Okay, So under some definition or some operational semantics, the identity relationship can be computed in a clock cycle in a constant amount of time.
Yes.
Okay. Okay. And identities for large, complicated recursive structures, identities can still be computed in a constant time.
Yes.
Okay. All right. And then they would be the same if you had a identical structure that you made a copy of it for garbage collection purposes, but outside the semantics of the language. If I said, make me a new foo and lay it out like this, I said, make me another new foo and lay it out, and the two layouts are perfectly identical, their identities would be different because I made two separate things. And I want to know that you can detect that in reasonable amount of time, you know, a couple clock cycles. I make a new large complicated thing. I can make a new large complicated thing. I want to know the two things are different. They're the same type, they have the same shapes and all kind of things, but they're two news, so they're two different things. How can I do that?
So they would have two different identities in that case.
We had two different. Okay, fine.
What I'm trying to avoid explaining is that there's a, you know, in terms of making definite black and white claims,
Yeah.
is that there are some objects that even if I make two new ones, they will have the same identity.
Okay.
And an integer or a Boolean, or, you know, there are certain examples of that, and that is itself an optimization, and it does introduce, you know, if you want to write a book about puzzlers, it does introduce some fun examples, but it's a purposeful choice. It's an engineering trade-off that we made.
Right.
We want 42 to equal 42
Right.
at an identity level, even if you instantiate 50 of them, right?
Yes. Right. And in fact, you've instantiated 50 and you've taken up 50 chunks of memory for them. But if you
Right.
go do pointer equality, you'll say, yeah, that's a pointer equality. Yeah. Okay.
Right.
Fine. That's an interesting slight
It's a-
variation. I'm close
It's
to
a
that.
reasonable engineering choice, but it's neither correct nor incorrect. If you
Yeah.
know what I
Right.
mean.
Yeah. Okay. Fine.
Bill,
Yeah.
did I
Right.
answer your question?
Me, yeah, I think that makes sense. Yeah, that's I mean, it sounds to me like if you're going to have copies of immutables, then like you said, comparing the reference would be able to tell you that it's equal, but not be able to
Right.
tell you that it's not equal. So if it's not equal, then you'd have to check the
Right.
semantic.
So in this case, there's actually a very fast, roughly 01 answer for the not equal as well, because when you move data for copy compaction, you always keep a forward pointer from the old to the new. So there is an 01 answer. I
Interesting.
mean, in theory, it could be 02, but 02 is 01, right?
Yeah.
So a constant order time, in other words.
Yeah. But that's a read barrier. And unless you're just saying that I only use the read barrier when I do this reference to identity or reference to equality step. The read barrier says, before I answer your question, I'll take an extra step to canonicalize the situation, which means I'll look to see you got a forwarding pointer. Mid GC, you got a forwarding pointer. I'll get the forwarding pointer. That's the new value. Okay, that's
Yes.
a read barrier if you do it in every step. It costs you some interesting performance. That's totally what the Azul collector does. The interesting performance numbers can be driven down pretty hard, but they're there.
So, and you'd only have that situation during a GC, yeah,
Yeah.
during
Yeah.
an instant GC.
Yes.
You
Yes.
have, Cameron,
Well, no.
directions. You just mentioned one pointing back, but I guess you have to have one pointing forward.
Right, exactly. So
Matter.
since you're comparing two of them,
Yeah.
you have one with a forward pointer and one without, so.
Yeah, and right. And you do check for the presence of the forwarding pointer every time. The act of walking through the forwarding pointer does a bunch of other work, including updating situations so you can never do it again. Sort of like a
So
disjoint union find.
we
set.
haven't actually implemented this optimization yet, so it's something we designed for, but didn't implement.
Haven't got it going. Yeah, fine. Right. Yeah, so I was talking about making, you know, my ints under the hood be boxed for typing purposes. If you declare that you want it boxed, I was going to allow you to have a boxed integer, which is different from an integer. Otherwise, I'll guarantee get rid of the box, and so I won't have this question, or it'll be, you know, you'll be carrying primitive int to primitive int. That's fine. But if you have a box, I was going to leave the box around. And you're saying that, no, we'll take an extra step. If you do this particular question where I want specifically to look at identity equality, we'll take the forward, what I call forward through the read barrier, take the read barrier cost, and then answer the question.
And the reason why the ints would still compare identically for their identity, while a more complicated graph might not, even if the bits were the same, is that the identity itself is an opaque concept. So it's defined only by interface, not by class. There is no, we cannot write the class for it in our language, if you will.
Mm-hmm.
Right. So the idea is when you ask the reference for the identity, you get something back. And in the case of an int, the identity is the int.
Right.
And that's why it works. So,
but for other things, the identity is just guaranteed
Pointer.
from all
Yeah.
other identities.
right. And the main reason it has to exist is for things like graph serialization, deserialization. Like it's hard to avoid it. It's hard to avoid the necessity for the concept of identity.
Right. Well, here I am in the land of cyclic recursive types, and this is a big problem all the time. Like a lot of the engineering code involved is making all that work out.
Yeah.
Yeah.
So just to clarify, Cameron, you do need pointers on the old one pointing to the new one, and pointers on a pointer on the new one pointing to the old one, because anybody
No.
can compare too.
No.
Because you're talking about going one direction. So
Yeah, it's one direction.
which direction? Forward?
Yeah. Always
Always.
forward.
Always going forwards because we can't find reverse.
Because what happens is at some point we actually drop.
Right. And when you drop that, you could follow and clear that.
So when we drop the old one, any pointer to the old would be, you know, an explosion waiting to happen. So you only point forward. And then the idea, generally speaking, and Arthur, you're probably much more knowledgeable on this than I am, but the idea is generally, and I think this is how Azul does it, you do a single clock test on the pointer, and then if you detect that it's, if you detect that there's a forward one to follow, you follow it at that point and clean up at that point. I think that's how the Azul GC works with the Provus GC.
I was a big part of that.
Ah, I didn't realize you were still there at the time.
Oh,
Let's have
yeah.
a question then. So if I have two references or handles or whatever you call them to,
Yeah, they're basically
I want to
handled.
see are they equal. If you said that you could tell that they're equal because of this forwarding part, it's only if I ask if the question is asked of the left-hand guy, or I guess you could go both directions. I mean, I'm just trying to figure out how. Oh yeah, I guess you could go with, you got two of them.
Yeah.
This one doesn't match, doesn't have a forwarding pointer. You check this guy if he has a forwarding pointer, and that, okay.
Yeah, you take them both to the end of the line and then you
Yeah.
compare.
Yeah,
Okay.
you right. You forward them both till they're done. That's a classic read barrier, and then you have the canonical answer, and you can ask the question in the one like bit compare. Yeah, and now you pay the forwarding cost overhead, which if you do on every instruction has, or every load from memory has some interesting costs, which is why you want to beat it down. And it has some interesting benefits in that your garbage collector has free reign to move objects about, can reshape objects, can individually move an object or individually reshape one object or class of them or whatever. You do all kinds of fun games with the collector as soon as you have a read barrier. And you don't statistically take the forward very often.
Right.
So the major hack for making that work performance-wise is when you detect that you have a forward in progress, you need the address of where the stale pointer was when you run off into the runtime to go deal. And then you update it so that it forwards, same as disjoint set union find does a find call. Typically it never moves, but when it moves, it rolls you all the way up and rolls everything it found on the way all the way up to the end. And that gives you the inverse Ackermann's, runtime. It gives you the extremely strong runtime guarantee because fix-ups are rare. That's what it amounts to. They are provably rare. Okay. Well, anything else? we're nigh on the usual amount of time, so it's all good. Okay. Next week we're on like normal around Christmas. We may or may not, I may or may not call it. If anyone has a giant thing they want to do, then, you know, we can worry about it then. I think Max wants to talk about inlining next week. That sounds good. All right. Till next week.
Okay.
Bye-bye.
Bye.
All right.
Yep.